Hello, greetings of the day. I am Mrs. Vinaya Tapkir, Assistant Professor from MIT Academy of Engineering. Now here presenting the next part of the video for task control block as a task control block part 2. In the previous video, we have seen and we have compared how we are writing the structure in a C with the structure which is written in the kernel, that is the task control block. In that we have seen the what is the name of the structure, that is the OS underscore TCB, which is written in a small case letters. This is the name of the structure. Then there are the multiple members of the structure, and OS underscore TCB written in a uppercase letter is the structure variable. This says that we can create the number of structure variables, that is number of OS TCB tables for the particular task, because the MuCOS2 is a multitasking operating system which can create the multiple tasks, and every task need its own task control block and the stack. Hence, the structure provides us to create the multiple tables for the OS TCB. So we have to keep in mind this is the OS underscore TCB is the structure variable. OS underscore TCB in small case letter is the name of the structure, and these are the multiple members of the structure. Now we have to see the each and every details. What is the purpose of this structure members? So we have to start the explanation of the each members of the structure. Obviously, all these members are located or situated in the memory block in a sequential manner because we have written the kernel has written the structure for that. So one by one we have to see the member of the OS-TCB structure. The first member of the OS-TCB structure is a OS-TCB STK PTR. This dot over here indicates this is the member of the structure. This is not a bullet, this is a dot operator used for the member of the structure. So OS TCB STK PTR contains a pointer to the current top of the stack for the task. Each task is having its own TCB and the stack also. So where the stack is located, this information or this address is present in this location of the task control block. So MuCOS2 allows each task to have its own stack, but just as important, each stack can be of any size. It is not limit that the stack size is the same for all the tasks. It is defined in the program itself. So this is the first location of the task control block. In the second memory location, the TCB holds the OS TCB extension PTR information. So this is the variable name for that particular location. This is the pointer to the user definable task control block extension. So sometimes it is needed that the tasks are extended or some extensions are needed. Then we have to extend the task control blocks also. So this pointer holds the information about that. So this allows you or the user of the MuCOS2 to extend the task control block without having to change the source code for the MuCOS2. Hence, the OS TCB extension PTR is only used by the OS task create function. In the previous video, we have seen the OS task create function and the just comment about the OS task create extension. OS task create function creates our application task, and when we have to extend that, we need not to change the whole program, just we will give the extension to that created task, and for that we need to create the extension for the TCB also. So this variable holds that particular information, and we have to set the OS task create extension enable as a 1 whenever we have to give the extension for the task. This variable is present in the osconfig.h file, configuration file. All these variables, all these configurations are present in the config.h file. I will create one more video only for the configuration.h file where we will see all the details about the configurations. Then the third variable .ostcb stk bottom. This pointer This memory location holds the pointer to the task stack bottom. Means where from what address the stack starts. This information is stored in the OS TCB STK bottom. Then the next variable is the next member we can say is the OS TCB STK size. Is the variable that holds the size of the stack in number of elements instead of bytes. Means how many elements are there, 256 bytes or 512 bytes or 64 kilobyte. That stack size, how much is the size, that information is held by this OSTCB STK size member. Then the next structure member is OSTCB OPT, is the variable that holds options that can be passed to the OS task create extension function. Then the sixth member are is .OSTCB_ID. This is the very important variable, is the variable that is used to hold the identifier of the task. Now in the MuCOS 2 version, this identifier location is empty. Now it is not created. This is kept for the future use. And obviously all these structure members are sequentially located in the memory. That's why we are saying that OS task control block is the memory block which holds all these parameters sequentially and which are very much essential to resume the task at the time of context switching. Then the seventh structure member is a OS TCB next and OS TCB previous. Here OS TCB next is having the separate memory address and OS TCB previous is having separate memory location. So .OS TCB next holds the address of the next TCB and OS TCB previous holds the address of the previous TCB, because all the TCBs are connected with each other in the form of doubly linked list. So I hope you have the knowledge of the data structure where there are the two types of the linked list, singly linked list and the doubly linked list. As the MuCOS 2 is the kernel, it has to keep the track forward and the backward also. So the TCBs are connected with in the doubly linked list fashion. And that time the linked list should have the address of the next TCB and address of the previous TCB also. So these addresses are located in this structure variable, members of the structure, OSTCB next and OSTCB previous. This chain of the OSTCB, so we can say the OSTCB is the chain. This is the chain of the OSTCB is used by OS time tick to update the OSTCB delay field for each task. So this DLY field is again plays very much important role to calculate or to understand how much time the particular task is in the wet state or is in the ready state. Again, the next member of the structure is a OSTCB event PTR. This is the pointer to an event control block. So again, this is a one more structure we can say whenever the block word is there, means obviously the structure is written to hold the particular members of this block. So like a TCB, there is a one more structure that is a ECB, event control block, needed for intertask communication. So in the next unit, we have to start the intertask communication. That time, in the next video, we will see the details about the event control block. Then the very much essential again, these are the four member variables, that is OSTCB BX, OSTCB BY, OSTCB bit X, OSTCB bit Y. So event control block and this ready list table, these are the two important blocks again resides into the RAM. That we have to helps to identify which task is in the run state and which task is in the ready state, to keep the track of that states, ready state and the run state. Task states we have seen in our previous video. There are the 5 different states of the each task: ready, run, wait, dormant and the ISR. According to that, we have task or the CPU or the kernel continuously keep the track what is the status of the task, and that status To keep the track of that status, these are the four members are helpful to identify the status. In the next video, we will see the ready list table. There we have to keep the every details of this variables. So these variables are used to accelerate. Okay? So the name accelerate the process of making the task ready to run, because ready run. This is a continuous process, and to accelerate, to make change the state of the task from ready to run, these four variables are very important. So this is the just listing written into the kernel. We have to see the details of this each instruction in my next video, that is a ready list table. So these are the very important members of the structure, means these are the memory locations of the OS task TCB. OS task control block helps to keep the or save the status of the each task at the time of context switching. Again, now the question is, how many TCBs are allocated for the particular task? So obviously it is depend on how much task is created for the particular application. See, the MuCOS2 is a scalable operating system where we can control or we can decide how many tasks are needed for the particular application. It is depend on the particular application, washing machine, fridge, whatever application we have to do, we can restrict the number of that. So one variable is assigned in the config.h file for that. The maximum number of tasks, the variable for that is os underscore max underscore task, that an application can have this specified in os config.h file. So I can restrict my task, number of tasks, and I have to give the value in the os max task in the configuration.h file. This value determines the number of OS TCBs allocated by the MuCOS2. So if the number of tasks are created 10, then only the 10 TCBs are allocated for us. Then this helps to reduce the amount of the RAM needed. That's why it proves that the MuCOS2 is a scalable operating system where the OS TCB tables are created according to the number of the task. By setting OS maximum task to the number of the actual tasks needed in the application. So we can make our MuCOS2 scalable. For example, if OS maximum task is equal to 10 in the osconfig.h file, then only 10 TCBs are allocated for an application. So that much RAM is utilized by the application. No vestige of the multiple TCBs are there, and so we can prove that the MuCOS2 is a scalable operating system. So here all about the task control block. In the next video, we will see the details about the ready list table. Thank you all of you.